Okay, I'm going to go over some summary and commentary things here for Section T5 using the key takeaway slides from our previous presentation. The current and voltage essentials. Now, let me just say up front that these are the sections that I think a lot of people, and myself included, even as a ham of over 30 years, some of these things are kind of difficult. They're hard to remember. Going back over the technician materials and even playing around with technician practice tests, some of these are hard to recall because, quite honestly, you won't use all this stuff every day. And even if you do use it some, and some folks don't at all, even if you do use it some, you have the book to refer back to. You have the internet now, Google, even the antenna formula that I have used for many years, and I use the one that converts the length of the antenna into feet. The test material now actually has you putting it in meters, but even though I've used that multiple times over my time as a ham, I still kind of look it up, or I'll get online and use some Google calculators or age or something like that to make antennas with, and they usually come out. I have a uncanny ability of whatever I plug into that formula, and I measure that antenna to be by whatever means I use to measure it, and then compensating for, if it's a wire antenna, a little bit of extra room for going around the insulator and all that. I've been very fortunate that most antennas I make have landed on being resonant where I want them to be without having to make a bunch of adjustments. So it's one of those things. If this stuff right here is really kicking your brain, don't beat yourself up over it. You can still make a very good ham and still have to refer to the book when it comes to dealing with a lot of these things. So, but for the test purposes, current, which is amps, I'm just going to pronounce it amps to make it easier, it's the flow of electrons. Voltage is the force that drives. One of the terms that I used to hear used when I was a young ham was volts was like pressure. It was like pressure in the line, and of course ohms is your resistance. You'll deal with that quite a bit because, like, your standard coax cable for amateur radio and citizens band and even GMRS is 50 ohms. So you have to be able to make that kind of match with your transceiver. That's one of the reasons that you can't use the coax cable from television, because it sets at about 75 ohms. You can, in the HF bands, you can make that kind of work, and I've done that before in the past. The biggest problem you run into with the TV cable, it is made a lot different, not as good of a quality, and the connectors that you use in amateur radio, which is standard, the PL259s, will not attach to that very well. You can get adapters that change that standard TV connector over to a PL259, and I've done that with receive-only antennas, but I don't do that much as far as any kind of transmission line. I just go ahead and invest in the 50 ohm stuff. In fact, since I'm running power, I get the thick LMR 400 style. The frequency in hertz measures complete AC cycles per second. AC alternates between positive and negative directions, and DC flows across one direction only. So as far as AC, if you are totally green to these electrical principles, this is something, though, that you will refer to a little more frequently in your path as an amateur radio operator. AC, alternating current, is what is in your home typically, and then DC is what you find in your car with your car battery. Most of your amateur radio equipment will run off of DC, so you have to get some kind of converter, which we commonly call a power supply. And there are different styles of power supplies, different types of power supplies. A lot of things have power supplies in them that converts your 120 volt to 12 that you maybe don't even realize you're using. Like a phone charger, you can't charge a smartphone off of 120 volts, so that little block that you plug into the wall actually converts that voltage to what it needs in the 12 volt range and reduces the amperage and all that kind of stuff. That's why in your car, you can just plug your phone charger into a USB port if it's in your car, or you can plug it into one of those accessory hookups and just plug that cord straight into that without the little block or anything. So power supplies are everywhere. Obviously, you can't use those little blocks to power a ham radio. They only put out 1.5 amps to 3 amps, something like that. And most of your amateur radio is going to require at least 12 amps or more, depending on your power level. Metals are good conductors because they have many free electrons. Any kind of metal like that's going to conduct electricity, you can run into issues because of that as much as you can run into benefits. Like in one of the sections where it talked about using the solid or round wire for ground and that kind of thing. It's a conductor, so it doesn't know RF and voltage. It doesn't know the difference. It looks for the path of least resistance and follows it, and so that could be your ground if you're dealing with that. Glass is a good insulator because its electrons are tightly bound. That was a comment that a friend of mine and I used to make quite frequently as a joke because we were dealing with some vehicles that we had that I had in particular. I was in a situation where I couldn't just mount an antenna somewhere on the vehicle in the metal portion or anything like that. So I ended up having to get one of those on-glass antennas. And you can imagine you compromise a lot using one of those because you're putting on the inside of the vehicle, there's a little box that comes with those, and it's basically a matching device to fool the radio into thinking that you've got a good 50 ohm match so your SWR doesn't run really high. Then it's dependent on trying to push that signal through the glass and up the antenna, which is maybe a resonant radiator, but you're losing a lot going through glass when you try to make an antenna do that. And resistance opposes all current flow, DC, AC, and RF equally. Any kind of resistors or resistance that's caused by any component in the line, whether it's your voltage supply or even your RF going out, that's all those things can be measured the same as far as resistance goes. And remember the water analogy: voltage equals pressure, current equals flow rate, and resistance equals pipe restriction. I encourage you on a lot of these formulas and everything to do some of the practice tests. And I mean this especially if you struggle with this kind of thing, because I very, very much do sometimes. And so I encourage you to look these formulas up and maybe get some practice stuff, or find these exact test questions and work these formulas out for yourself and see if you can get the same answer as what's given if you want to go that far with it. But also bear in mind one thing, especially when we get into that D section where there's a lot of that, is each one of these sections is one question on your test. So I'm not trying to say just throw it out and say, well, if I miss it, I miss it. It's only one question, or take a chance on it, on getting one of the questions that doesn't involve all the math and all that. But I also say that to don't overly stress this section or anything, because it's just a few questions on the test, and if this is something that you majorly struggle with, then you could still make it, even if you do just miss every one of these. You severely reduce the amount of room you've got to be able to pass the test, and I doubt you would miss every one of them. You'll probably get some questions that you are more familiar with, especially if you use some of the memorization method. But don't let this get you discouraged or anything like that. Don't overly sweat, especially like this section I have up here, this T5B. These metric prefixes, the pico, micro, milli, kilo, mega, that'll help you a lot to memorize those, because you'll get those questions about those, and you don't have to do any kind of math formula necessarily to figure those out as much as just moving commas and decimals and everything, and then convert up milliamps to amps, kilohertz to megahertz. You divide by 1,000 or move the decimal 3 places to the left. So there are some little tips and tricks that you can do on these where you're not overly engorged in the math itself. One of the things that I do in the course of my job is accident reconstruction. If there's a car crash that involves a fatality, then I'm a part of a team that we go out and we kind of rebuild that crash, and there's a lot of math involved in that. And of course, these days you plug everything into the formula. Before I became a crash reconstructionist, I didn't know diddly squat about these formulas outside of what I learned taking amateur radio tests. And it kind of dawned on me after I got into the crash reconstruction that all these formulas, you need to take your known values and then you can kind of plug them into these formulas to get your unknowns. And I know a lot of you, there may be out there thinking, well, duh, that's kind of how it works. It for folks like me that kind of struggle with this stuff, it was kind of an epiphany when it finally dawned on me that I just need to organize my information, write down what I know, and then see what the question is asking for that I'm lacking, and then refer to the formula that can give me that information. And it usually involves all the same. If you're missing the I or whatever, then you've got the and you've got the R and that kind of thing. Somewhere along the line, you've got to group that information and either add, subtract, multiply, or divide it to come out with the right answer. And especially in this environment, you're dealing with a multiple choice test, so you can kind of narrow it down. Even if you get things a little bit backwards, they should come out and not make any sense, and then you can rework it the other way, and then you're like, oh, this is the way it's supposed to go. That's sort of how I reason through some of these things. Remember, the capitalization matters on these abbreviations like megahertz and milli and all that, kilohertz. The case, the capitalization, lowercase, uppercase, all that does matter, and it is different. So just kind of run through those as well, outside of just reading the test questions and answers, and that will help you when you get to that series of questions. And then T5C, there's a mnemonic here that mnemonic, however you pronounce that. I jokingly say that my version of studying for this test is like the hillbilly translation, but it's magnetic field, inductance, capacitance, and electric field, and both store energy in different types of field. The power formula is P equals E times I, and then you can rearrange that and figure any one of these other components through division. And then, of course, this is your second essential formula alongside of Ohm's law. And then impedance is opposition to AC current flow, and that's measured in ohms, and you will hear that quite a bit throughout. If you further yourself in amateur radio and continue on, even at the technician level where you're just dealing with the above 50 megahertz mostly type stuff, a lot more plug and play type stuff. As far as you can buy a radio, you can buy a piece of coax cable and an antenna, and you stick it all together in a power supply, and then you're on the air. You can still build antennas at that level and do things like that. So you'll need to know some of this stuff, but you'll hear the impedance quite a bit at the 50 ohms coax. And then RF is radio frequency signals of all types. So that's a common abbreviations, kilohertz, KHZ, megahertz, gigahertz. And then 13.8 volts. That is the standard ham radio power. You will see that once you get your license, if it's anything like it used to be. It's been 20 years or more since I even did my last upgrade. But once you get your license, if it's anything like it used to be, the folks out there will pick up on these new ham licenses, and you'll start getting catalogs and all this kind of stuff in the mail. And as you look at power supplies, whether it's there or you're looking on eBay, that you're going to see that 13.8 volts repetitiously. You will remember that because it becomes a big part. It becomes part of your language at that point. And then section T5D, Ohm's law and circuit essentials. Ohm's law, of course, these three formulas right here, and that covers what you need to know. In the EIR circle, side by side means multiply, and top over bottom means divides. So remembering that will help you. Whenever you take the exam, of course, you can take a calculator with you if you want to work those formulas out and do it that way. You also have the option of the fact that you have the exact questions and answers right here in front of you, and hopefully you're either using a study book or you're getting online and doing practice tests, and it's the same way. The practice tests are the exact questions and the exact answers. So if you struggle with this kind of math, try to remember as much of these as you can as you go through, and don't sweat them too much, because each one of these little sections is only going to be one question out of the 16, 13, or 12 that are on there. So I would venture to say out of these sections that even if you're struggling with it, reading and knowing the exact questions and answers, you might miss one, maybe two, or whatever in the section that you would struggle, or at least I would struggle the most with. So the parallel circuits, the voltage is the same across all branches. The current divides between branches based on component values. And one of the ways that you might use, I don't know that you would, but depending on your field day activities and all that kind of stuff, like parallel, if you take two 12-volt batteries and you connect the positive to the positive and the negative to the negative, then you're paralleling that circuit, and the amperage, the amps, is what you get the benefit of, because it remains a 12 volt on the other side. Whereas if you connect the positive of one battery to the negative of the other battery, and then you are using the positive and the negative that are left available, you're combining the voltage of those two batteries and you're getting 24 volts. So that might be a way to kind of remember how some of that works. And the memory aid, if I didn't cover that already, for that is series equals same current and single path, and parallel equals same voltage and split paths. So that is my summary commentary on the T5 section. It, to me, is one of the more complicated ones because it involves a lot of math, but as my time in amateur radio and my time as an accident reconstructionist went on, it is not as scary as it was when I initially got into the hobby years ago as a teenager and was really afraid of these kind of things. So I've had a lot of folks that during exam sessions where I've been a VE that talked about struggling with the math of it, and at the technician level, it's not going to impact you as bad. When you get up to extra class, there's going to be a lot of this on there, and even with my struggles, I did pass the extra exam. Now, I took it multiple times and eventually just passed it with no room to spare, but for 20 some odd years, I've kept it renewed, and I'm still as much an extra as someone who might have aced the test. So anyway, there's that one. We'll move on next to section, not sure why that changed right there, but we'll move on next to section T6. So you're over halfway there.